Hello, Phoenix mathematicians. So it is Miss McGinnis here with you. I am going to be going through this worksheet with you, adding and subtracting polynomials. So you should have this handout from the substitute from Ms. Tilly. And we're going to work through some examples together, and then I'm going to leave the independent practice for you guys to do on your own and to turn in. Okay, so today what we're looking at is adding and subtracting polynomials. So polynomials is a very big topic in all of your math classes, and this is a very important skill for you to be able to do so that you can move forward in your math. Okay, so I do very much enjoy colors, and I think it really helps things to stand out. So if you are one that enjoys colors as well, or you realize that that's something that as we're working through these, that's something that helps you, please feel free to get you some colors and to use colors on your own paper. Alright, so we are adding and subtracting polynomials. So let's start with number 1. Alright, so the operation with number 1 is addition. And we like addition. Addition is tends to be a little more simple than subtracting. So with addition, we are going to take and look at all the different terms that we have. So if we think about our terms, so we have 1, 2, 3, 4, 5 different terms. So we have 5 different terms. Okay, and what we want to do with those terms is we want to add the ones that are the same. So if you remember combining your like terms. So if I look at 6n squared, I want to 6n squared, so I don't want the minus with that. So I want to combine all the terms that have an n squared. So I'm just kind of looking through. The other one that we have that is an n squared is 8n squared. Okay, and so that is all of our n squareds. So what we're going to do is 6n squared plus 8n squared. Well, that makes 14n squared. Okay. All right, up next, let's see what our next term is that we're going to look at. So let's say we look at our next one here is a minus 4n. All right, so I got a minus a negative 4n. We're going to add all our n terms together, so plus. So I'm just kind of scanning through, looking for any of the other terms that have an n, and I see a plus 4n right there. Alright, so what's going to happen there? So minus 4n plus 4n. Well, if you subtract 4n and then you add 4n, that is 0 4n. Negative 4 plus 4 is 0. And we're going to simplify this down in a little bit. Okay? Alright, and then the last, we got one more thing on here, and that is that minus 3. So I'm just going to look for all my numbers. So my constant terms, my constant numbers. Alright, so I'm looking through. I don't see any. So that is going to be a minus 3. Okay? So our final answer here is 14n squared. We generally don't write 0n, so I'm not going to write it this time. So 0n, we're going to leave that alone, minus 3. So that is our final answer on that one. So we took our like terms and combined them together. Alright, let's take a look at example 2. And this one, alright, so take a look at this one. This one is a subtraction. Okay, so we're going to have to deal with the subtraction. So let's see how many terms we have. We have 1. Oh, let me get my marker here. Alright, so we have 1, 2, 3, 4, 5 terms on this one as well. And again, we're going to try to combine our like terms, but I'm looking at the fact that there is a negative, a minus in between these two. So actually what I'm going to do is I'm going to rewrite this. So I'm going to have negative 7a squared plus 2. Nothing's going on there, okay? But what I'm going to do with this minus is I'm actually going to distribute it in so we're not dealing with that minus there. So negative times negative 5a is going to be a plus 5a. Negative times negative is a positive. Okay. Negative times negative 9a squared will be plus 9a squared. Okay, and then a negative times a positive 4 is going to be a negative times a positive is negative, so minus 4. Okay, so that helped me change from a minus to a plus, which makes my life a lot easier. All right, so now what we're going to do is we're going to come in and combine our like terms. So let's take a look at what kind of terms we have. So I'm just going to start. So this 7a squared, or negative 7a squared. So I'm looking for all the terms that have an a squared. So when I come through and I'm just looking, oh, here's one right here. We got a positive 9a squared. So negative 7a squared plus 9a squared. So negative 7 plus 9 is 2a squared. Alright, let's take a look at our next term that we come across. Alright, so let's take a look. The next one that I see is this plus 2. So that is a constant, that's a number. So let's find any other just numbers going on. And I do see this minus 4 hanging out here in the back. So plus 2 minus 4. Positive 2 minus 4. So that's going to be a minus 2. Okay. Alright, now we're going to come through and look at our next one. Alright, so the next one here we have is 5a. And I do not see any other terms. I took care of all of our terms. So we're going to have a plus 5a. Okay. Now, for our final answer, we're going to write this in standard form. So if you remember, you took some notes earlier about standard form. So we're going to start with the term that has the highest degree. And degree, remember, is your exponent. So the term that has the highest degree is this pink 2a squared. All right. So that is going to stay at the front. So 2a squared. And then we're going to go down from there. So the next term that has the next highest exponent. So 2 is the highest exponent. The next one would be 1. All right, so we're going to look for the one that has a 1. And that's this green 5a. There's an understood 1 there. You remember we kind of talked about that. There's an understood 1 there. So 2a squared plus 5a. Okay. And then after 1, after an exponent of 1 is an exponent of 0. If you remember, that's your constant term. So that's my minus 2. So I've got that written in standard form right there. All right. Example 3. All right, so example 3 says, what expression represents the sum? Oh, that's a term right there. That's a term we want to kind of point out. So we're talking about the sum of 7 minus 4b and 6b squared minus b plus 8. So we want to think about sum. What sum means is addition. Okay, so we're going to add 7 minus 4b we're going to add it with 6b squared minus b plus 8. Okay. Alright, it is a plus. It is an addition problem. So let's jump in and start combining our like terms. Alright, so I'm going to start just from the left here. I got 7. Okay, so I'm looking for all of my just numbers. I'm just kind of scanning through and I see I've got an 8 out here. Okay, and then 7 plus 8 is 15. Okay, And now we're going to look at our next thing that we've got going on, which is a minus 4b. So I want to look for all of the terms that have a b to the first power. So I have a minus b right there, okay? So minus 4b plus a minus b, a negative 4b plus a negative b. So that is minus negative 5b, okay? All right, now coming in with our next one that we want to look at is 6b squared. And actually, that looks like that's our last term. So I don't see any others that I can combine that with. So plus 6b squared. Okay. Now what we're going to do is we're going to write this in standard form. So if we think about what's going to come first, so 6b squared, that one's the one that has the highest exponent, so 6b squared. All right, and then minus 5b to the first power, because you start with b to the second power. Now you're going to go to b to the first power. We typically don't write it there. And then your constant term, the 15. Okay? All right, and the last example that we're going to work on the front side of this paper is example number 4. It says, what expression represents 5x squared minus 6 taken from? So we gotta highlight that and see, remember what's going on there. So taken from. So this is subtraction, okay? And we gotta be careful because it includes that word from, okay? So if you see the word from, you kind of think about flipping it around. Okay, so what expression represents 5x squared minus 6 taken from negative 4x plus 2x squared plus 3. So again, this is taken from. So that's going to tell me that that second one is going to come first. So we're going to start here. That's where we're going to start. Okay. So because it says taken from, we're starting with that. Alright, so we're going to start with negative 4x plus 2x squared plus 3. And then we're going to take from that 5x squared minus 6. Okay? Alright, so what we're going to do, just like we did in example 2, where we had that minus, we're actually going to go ahead and take that and distribute it through. So negative, I'm going to rewrite my first one. So negative 4x plus 2x squared plus 3. That's my first one. Alright, and then what we're going to do is actually take and distribute that negative through. So negative times positive 5x squared is going to be negative 5x squared. And negative times the negative 6 is going to be plus 6. Okay? Alright, and then we get to bring in our colors and combine the like terms that we've got here. So I'm going to start from the left. Some people do it different ways, and that's fine. I just start from the left. So I'm looking at negative 4x. So I'm going to kind of scan through all of my terms and find my x terms. And actually looks like I don't have any more x terms. So negative 4x is just kind of hanging out by itself right here. Alright, so let's look at our next term, which is a positive 2x squared. Alright, so let's see if we got some more x squareds. Oh, we do. We do have another x squared here with a negative 5x squared. Alright, so I'm doing plus 2x squared minus 5x squared. So 2 minus 5 is negative 3x squared. Alright, let's look at our next term that we've got going on. And we've got a constant, so the number 3. And I'm just going to scan through. I've only got one more left, and that's this 6. And that will combine with that 3 because they're both numbers. Okay? So 3 plus 6 is 9. Alright, so we've got that written out. And what we want to do, kind of finish this off, is write it in standard form. Alright, so my highest degree is a 2. My highest exponent is a 2. So that negative 3x squared is actually going to be in the beginning at the front. So negative 3x squared. And then we're going to come with our x term, which is minus 4x. And then our constant term, which is 9. And there we go. So that is the problems that you can definitely refer back to when you're doing the independent practice at the bottom of the first page. Okay. Now we do have a little bit of stuff going on here with the 2. So I just want to point this out real quick for you with the 2 happening right here on example 5. So if you think about what are you going to do with that 2? Well, actually what you're going to do with that is distribute it in. Okay, so you distribute that 2 into the parentheses there. So I'll get you set up with this real quick. So we're going to keep this first one here. So it's a negative 5n squared plus 3n. But on the next one, what we're going to actually have when we distribute 2 into the parentheses is negative 2n squared. 2 times negative 6, so negative 12n. And 2 times 1 is plus 2. So we just kind of distribute that 2 into the parentheses. And that makes a lot more sense. Okay? So you definitely can do those. Alright, let's take it up a notch. We love taking things up a notch. Let's take it up a notch with the back side of that page. Alright, so you can finish if you want to pause right here, I would love for you to pause right here and go ahead and do the independent practice on the front. And then come back so that we can look at exercises 9 and 10 so we can go through that together. Alright, exercise 9 says determine the expression for the perimeter of a rectangle with a length that is 5 less than twice its width. 5 less than twice its width. Alright, I am a very visual learner, okay? So I like to kind of draw these pictures. So I got a rectangle. So I'm going to draw a rectangle. Okay. Rectangle with a length that is 5 less than twice its width. So you remember last week we had some stuff going on here. So a length that is 5 less than twice its width. Length that is 5 less than twice. Alright, so we got the width. So let's just label that W. That's our width. The length is 5 less than. So that means this next part actually comes first. So 5 less than, so twice its width. So let's do twice its width and 5 less than that. So we're going to subtract 5. So that's what we got going on. This is what the picture looks like, the image looks like. Okay? Now, the big idea, what we're trying to find in this problem actually is the perimeter. So we're trying to find the perimeter. So if you remember, perimeter is you add your sides. Okay, so when we think about a rectangle, we have 2 widths and we have 2 lengths. And in this case, our lengths are 2w minus 5. So we have 2 widths and 2 lengths that we're adding together. Okay, so I'm just going to keep going with this. So 2 widths. We're going to take and distribute here. So that's going to be plus 4 w. 2 times 2 is 4. And then 2 times minus 5 is minus 10. Okay. Now what I'm going to do is I'm going to look through here and see if I got any like terms. So I'm just going to start with 2w. I'm going to looking for any terms with a w. And I got a 4w. So 2w plus 4w. 2 plus 4 is 6w. Alright, I'm going to come back, I'm going to look, and I see I have a minus 10. There are no other terms. So 6w minus 10. And that is actually already in standard form. So 6w minus 10. Alright, number 10, again, perimeter. Alright, so we're looking at perimeter on number 10 as well. So the perimeter of the triangle is 15n squared plus 8n minus 9. We want to find the length of the third side. Oh, this is a fun one. Okay, so we have two sides already. We already have two sides. But we don't have that third side. That's the one we're trying to find. So we got to figure out what is that third side that would give us our total perimeter of 15n squared plus 8n minus 9. Okay, so let's take a look at what we've got already. So we're going to take a look at the fact that we have 6n squared. Let's see. Let's put these together. So we have 6n squared plus 4n minus 3. And so I'm going to run out of space if I try to keep going. So I'm going to do something a little bit unique here. So I'm going to add, and I'm going to put right below it. So we're adding. So if you remember addition back in elementary school, you probably added them on top of each other. So I'm actually going to do that here. So I have 6n squared plus 4n minus 3. I'm going to add 7n squared. So I'm putting my n squareds in the same column. Okay. Plus 5n. I'm putting my n terms in the same column. And then plus 7. So right now I've got all my like terms are in the same column, which is kind of nice. It's kind of nice to do it this way. So n squareds. So when I look at my n squared, 6n squared plus 7n squared, so that's 13n squared. Okay. Alright, let's look at our next one. So our next column, we have our n terms. So let's see, 4n plus 5n, that is 9n. That's good. And then our last column here, all lined up real nice for us, is minus 3 and plus 7. Minus 3 and plus 7. So that's a plus 4. Okay. So total right now we have 13n squared plus 9n plus 4. Okay. However, our perimeter is supposed to be 15n squared plus 8n minus 9. So I got to figure out what's left so we can get that third side. So to figure out what's left, we're going to subtract. So we're taking both addition and subtraction in this problem. Isn't this so much fun? Alright, so we have 13n squared. I'm just going to rewrite this. Plus 9n plus 4. Oh, wait. Let me go back. Let me undo this because we've got to subtract that from. So remember, we're going to subtract that from 15n squared plus 8n minus 9. Okay. And we're going to subtract. Now, I kind of like this column setup. So I'm going to do this one like a column as well. So I'm going to subtract 13n squared. Let me clean this up a little bit. I'm running out of space. So let me clean this up a little bit. By the way, this that I'm using, you guys also have access to this as well. It is called Sketches School. So if you've not used Sketches School, it is pretty neat to use, especially if you like to draw. If you like to draw, this is something that's in self-service. Alright, so I'm going to set this up a little more neater so I have a little bit more space. So I have 13n squared plus 9n plus 4. That's what we have with the two sides. But the total perimeter is supposed to be 15n squared plus 8n minus 9. So I got to subtract 13n squared plus 9n plus 4 from 15n squared plus 8n minus 9. So I'm going to start with 15n squared plus 8n minus 9. And I'm going to subtract 13n squared. And I'm going to put it in parentheses because I got to subtract all of this, not just the 13n squared. So subtract 13n squared plus 9n, that's supposed to be a 9n plus 4. So I'm subtracting all of that, okay? Alright, so let's start doing that. So 15n squared minus 13n squared. Well, that is 2n squared. Okay. 8n, let me get my colors going with us here. Alright, so 8n, we're going to subtract. We've got to keep in mind that we're subtracting. 8n minus 9n, which is 8 minus 9 is negative 1. So minus n. Okay. And then our last thing here we've got going on is minus 9 or negative 9 minus 4. So negative 9 minus 4. And if I am at all unsure about what is going on, I'm going to grab a calculator. Alright, so negative 9 minus 4 is going to be a negative 13. Okay, so that third side has to be 2n squared minus n minus 13. Alright, so you have now some practice problems of your own. How exciting. Alright, so your independent practice on this one. So again, you're looking at similar to the problems that we just did. You have some perimeter, a couple of perimeter examples, or all three are perimeter examples. And be sure that if you need to draw a picture to visualize what's going on, definitely do that. I have to do that myself. So if you will do those independent practice problems and submit those, I will try to take a look at those and give you some feedback soon. Have a good day.